Hey, welcome back everyone. So this is going to be the third and the last video for 4.1, and in this we're going to look at coterminal angles. So when something is it's there's a relationship. It shares the same terminal arm. So that's the definition here we're giving you. Coterminal angles share the same terminal arm, such as, for in this example, 70 degrees. It could either be 70 like it is here, or we could also take another full revolution and it would end up being at 430 if we add the two together. All right, so that would look like this. So you start here and you would take a full rotation of 360 degrees up to here, and then you would go a little more, that 70 extra, and this actually shows you what 430 degrees look like. All right, so you would add on one full revolution counterclockwise. Now, if we look at this case here, so this says 70 degrees minus 360. So if we're going in the opposite direction, so it's important. That's why I'm going to restate this again and again. It's important to show this arc or this arrow to show which direction your angle is going. So for this one, if I'm going in the opposite direction, I'm going to start here. This is my initial arm, and then I'm actually going to go around, and I'm going to end up at my terminal arm, which is right there. So what I've done is I've gone negative 290 degrees. So one full revolution clockwise, you could also add another one. If I just kept going one full revolution, then that would give me another coterminal angle. So for here, I can keep going around and around in full 360 denominations. So that's what we've got summarized right here. Is the coterminal angle can be found by adding or subtracting revolutions, either plus or minus 360 degrees when we give a degree measure, or plus or minus 2 pi when the given radian measure, so if they give you like pi by 6, then you would add the 2 pi to that and get your full revolution out of that. All right, so we've got a couple of examples just below. It says, example 1 says, determine 3 coterminal angles for 40 degrees. Now, for 40 degrees, so what we're going to do is we're going to first draw what our 40 degrees looks like, and I'm just going to estimate that it's around here. It's not quite halfway in between, but it's, let's say, there. So this is my arc. I'm going to show that's 40 degrees right there. All right, now if I want to go plus 360, I need to find something that's coterminal to this one. So I go one full revolution, and then I go 40 more. So this ends up being 400 degrees. So this line right here, that's my 400 degrees. All right, if I were to go around another full 360, then that's when I would add 720 to it. And here I would get 760 degrees. I could also go in the opposite direction. So I could start here and then go around here. And that would, I would have to start, yeah. So I would subtract it. And then this from here to here, I'm going in the negative direction. And notice that I don't end up actually going a full 360. I end up getting stopped 40 degrees short to get back to where I started. So that's going to be negative 320 degrees. All right, so all of these numbers, all of these arcs that are shown here, I didn't show this one here, but these other ones, they all are coterminal to 40 degrees, which means that they have the same terminal arm. All right, now the second example on this page says determine 3 coterminal angles for pi by 6. So this is where we're going to use our multiples of 2 pi. So here I can go one full revolution, and let's see, pi by 6 is around here. I can go one full revolution, which would be from here all the way there. And that would come out to being pi by 6. And you want to get your common denominator for the 2 pi. And that's going to give us 13 pi by 6. Now, if I go another revolution, again, another 2 pi, then I simply add another 2 pi to this number. Or you can take the 13 pi and add 2 pi to that as well. So let's just do it in this form here. So we'll go pi by 6 plus 24 pi by 6, and that gives me 25 pi by 6. Make sure there. All right, now I could go in the opposite direction. So I could start here and then go that way. And this is going to be my -1. This is going to be my pi by 6 subtract 12 pi by 6. And that's going to give me negative, 11, this should be an 11 pi by 6 over here. So this is my negative 11 pi by 6. Okay, now let's move on to the next page. We're going to do a couple more examples with coterminal angles. Here, this one says, find a coterminal angle to 740 degrees over the interval -360 to 0. So this means that we're kind of going in the opposite direction, right? But we still have the same approach. We start with what we're given, and then we are going to subtract full revolutions until we get a number that is in this value. So first, this is going to result in 400 degrees and, 380 degrees. I don't know where I was looking. 380 degrees. And then this one, I subtract, this is going to give me 20 degrees. Now, this isn't quite in the range that I need, right? I want it here. So I need to subtract another full revolution in order to get it in this domain. So I need a number that's in between 360 degrees and 0 degrees. So let's do that. So we are going to take the 20 degrees that we ended off with, and I'm going to subtract another 360 degrees, and I'm going to end up with negative 340 degrees. So this is what I am looking for to satisfy this right here. All right. This one here says determine all the coterminal angles of 5 pi by 3 to over the interval -4 pi and 2 pi. All right, so before I can find the coterminal angles, and what I'm going to do is I'm going to add or subtract multiples of 2 pi. I'm going to convert 2 pi so that it's written in a fraction that's common to 5 over 3. So I pretty much just need a common denominator of 3. So if I have 3 here, then I'm going to have 6 pi up there, and that reduces to 2. So this is what I'm going to be using. All right. Okay. So now I'm going to take my 5 pi by 3. I'm going to add 2 pi to it. And that is going to be 5 pi by 3 plus 6 pi by 3. And that equals 11 pi by 3. Now I need to check the interval. Okay. Does it fit in here? Well, I don't think so. Okay. But you can double check that. And let's check here, 5 pi by 3. So we're going to go in the opposite direction and see if we can find one that fits. So 5 pi by 3 minus 6 pi by 3, that gives us minus pi by 3. So negative pi by 3. All right. If I want to, let's see what we're doing now. So this one, check this interval. Does this one fit in here? It might be a little tough to check, so why don't we rewrite this so that it's in terms of thirds so we can better compare. So negative 4 pi is going to be negative 12 pi over 3, and 2 pi is going to be 6 pi by 3. Okay. So now you can clearly see that this one here, this 11 pi by 3, it doesn't fit in this interval. So let's cross it off. And then let's figure out this one here. This, it looks like it does fit. It'll fit right nicely in between. All right, so this one works. We'll take this one. Okay, now, is it possible that we can take this, let's see if there's some more answers. So let's try to take this number and subtract another 2 pi from it and see if we can get some more solutions, okay? You need to exhaust all possibilities. Pi by 3, so let's minus the 6 pi by 3. And if this fits, then I know I can take it. So this one will fit within this range. So we're also going to take this. Now, just to be sure, let's do another revolution in the same direction. So I'll take my 7 pi by 3 and I'll subtract another 2 pi from it. And if this works, then I'm going to have to check another one. If it doesn't work, then I can stop. And I know I've completed everything because when I went in the positive direction, it didn't fit in the interval at all. So I went in the opposite direction. This fit, and let's see if this one fits. So this is minus 13 pi over 3. And lo and behold, it is out of this domain here. So I can cross this off and stop. So this is your answer, and this is your answer. All right, now the last one here before you guys have some textbook questions to do is express the general form, a general form for all coterminal angles of 5 pi by 3. Now, the definition of coterminal is that it shares the same terminal arm. We write this as theta equals 5 pi by 3 plus or minus 2 pi n. Now, this is multiples of 2 pi, so full revolutions. And then here, this we've got n is an element of the natural number set. Now, n is, we call it the natural number set, and we have to use the natural number set because 0 is not included. And if we include 0 in this answer, then it will land actually exactly on 5 pi by 3, and we don't want that because by definition, 5 pi by 3 is not coterminal to 5 pi by 3, it is 5 pi by 3. So just a little bit of notation there. Hope you had fun. I had tons of fun making this video. Good luck doing your homework, and we'll see you soon.